Thank you, Mark and Mariante, invited me to give a presentation of a paper we already published in International Journal of Epidemiology, but it fits very well in this symposium where we propose that live birth selection bias may affect a lot of work we do in birth cohort, and we run a simulation study under the context of prenatal exposure to endocrine disruptors and neurodevelopmental outcomes. So this morning is a good setup that feeder programming, live course epidemiology, often we aim to look at very early prenatal and early postnatal exposure effect on the long-term health outcome. But the challenge here is a missing denominator, which has been recognized a lot in reproductive epidemiology. When we study congenital malformation, birth outcome, we often term those are prevalence outcome because we know we do not follow all fetuses, and outcome among the aborted fetuses often are not recognized and not captured. But this problem has less been recognized when we look at childhood outcome, and few quantitative bias analysis have been ever done in this area. So this diagram kind of summarizing that it has been proposed and estimated as maybe only 30% of all conceptives eventually make it to live birth. A significant portion of them were actually lost in a very early period, we call early pregnancy loss, and they are often not clinically recognized. Actually, I see Alan Wilcox sitting there. He did a lot of pioneering work, estimating what is the proportion of early pregnancy loss. But when we talk about miscarriages, they are clinically recognized and might be found from medical data, but they are a smaller portion of the loss we actually talk about. This kind of highlight the magnitude of the selection bias we might be dealing with. So what inspired this work was that one of my dissertation paper, we looked at serum markers, serum measure of perfluorinated compounds in early pregnancy around weeks 9, and we correlated with the childhood ADHD diagnosed at age 7 to 10 in the Danish National Birth Cohort. What was unexpected to us was that we found that the highest quartile of exposure for several PFAS, we found a protective association. And this has also been noticed in several other cohorts in Sweden, US, Taiwan, and also Dutch cohort found unexpected inverse association for this compound and childhood ADHD. So at the time, some possible biological or causal explanation has been suggested, such as this chemical might effect on PPAR alpha or gamma nuclear receptor that might induce unexpected neuroprotective effect. But for us, we would like to also explore some non-causal explanation, and we were interested in selection and confounding bias. At the time when we did the study, there's also another study in the Danish National Birth Cohort have shown relatively strong association for having higher level of this compound related to longer waiting time to pregnancy. So that might be indicator for lower fertility, or subfecundity, which the woman have with exposed have a more difficult time to conceive, that for also being enrolled in our cohort, but also could be a marker for early pregnancy loss that the women have to try more time, couple have to try more time to eventually conceive. But this part of the data is less replicated, is still non-consistent compared to other cohorts, so it's ongoing investigation. Third spot is also 2 human studies that show moderate effect size for prenatal exposure to PFAS and miscarriage, mostly spontaneous abortion in 2 cohort study. So we did a simulation study using the Danish National Birth Cohort where we take all the prior information for the variable that we simulated. We would like to estimate it, changing the prior to see how large this live birth selection bias may have explained this unexpected finding we find for PFAS and childhood ADHD. The bias mechanism is summarized in this DAC, which when we have an environmental chemical that could affect on selection, and they might be other unknown or unmeasured factors that also affect on selection. and risk factor as an outcome, when we're conditioning on the subset, which is the survival, we may induce a collider or spurious association between these two variables, which is not what we want in analysis. So we did several scenarios. I don't have time to go through all of them, but the first one was that we assumed that prenatal PFAS exposure may affect on chance to conceive, also early survival, so effect on the risk for early pregnancy loss. In the DMBC, we enrolled 100,000 women during week 6 to 12, so this is like the setting of the cohort, but also has a chance to influence on miscarriage. And then we simulated some known and measured risk factors that we have the data in the DMBC, such as socioeconomic factors, maternal smoking, and other diseases that might affect selection and also childhood ADHD. But we hypothesized that there are other unknown factors. We don't have data such as genetic factors, hormonal markers, and other environmental chemicals could also lead to selection and the outcome that this is the path that might induce some collider bias that we cannot control for. So the first scenario, we assume that there's totally no effect on PFAS and ADHD, but we also hypothesis we started research was that PFAS might have a causal positive effect on ADHD, which we assume a small effect, which is 1.2 as a truth, or a moderate effect, which is odds ratio 1.5 as a truth, and see how the bias may affect this association if this is the truth. So I'm gonna skip the priors, and the simulation processes has been explained in the paper. So this is the main result I'm going to talk about. So it's a little bit busy, but in the first kind of like row, they're up there when we say is association for exposure and selection 0.8 there means that there's 20% reduction of chance for the conceptors to make into each state of the selection. And then the bottom row there is when exposure have a moderate effect on the selection at each step, which is 50% chance reduction to make it into the next stage. And then the three columns from left to right is that association from the unknown unadjusted risk factor of ADHD that might affect on selection. This is a collectively factor, so we assume they have 20%, 50%, or even stronger 70% chance of reduction raise chances for surviving. What also look at is how strong is the risk factor for ADHD. We hypothesize 2, 5, or 10-fold increase for ADHD. But what's to look at is that when the exposure has small effect on the selection, the true is 1.0, but then when we restrict it into the surviving set in our simulation, we see some small negative bias. Even the strongest prior that we give, it goes down to 0.94, so it doesn't really go down too much. But when the exposure have a considerable effect on the selection, when we're conditioning on the survival subset, we would see a larger, which up to 0.81, and adjusted odds ratio, even when the PFAS has no effect on ADHD among all fetuses of all conceptors. So this is kind of matching with what we see in our data. But when there is a small positive effect when we assume that PFAS has on ADHD in the total population, the bias is also in the same direction, in the negative direction, but only a few estimate cross a null. But they are all towards a null, depends on how strong the bias we assume to be. When there's a moderate true positive effect, again, is biased towards a null, but none of the effect size actually cross a null, go to the negative direction. So we also did a more complicated scenario where we consider confounding and selection. I don't have time to go through that, but what we did was that we found that confounding in this situation might be stronger. So the net bias effect is actually kind of driven by the confounding, but we want to highlight that this is more like real life. We have multiple biases going on. These biases depends on the direction that might cancel each other, or that they might add into a similar direction and amplify and make it stronger, the biases we're dealing with. So in discussion, this was a baby version of simulation that we did. We're trying to do more complicated simulation, looking at multiple exposure and considering the interaction with other risk factor on survival, and see whether we get a stronger bias or unexpected direction that we didn't expect it would be. Also, we would test a full range of prior instead of just selecting a few points that in our scenario. So in summary, we propose that LIEW bias may arise and affect our analysis on looking at prenatal exposure and child outcome, given that if the exposure could affect on fetal losses, the magnitude of bias is generally small in the prior that we tested. So one way to address this bias could be if we can find out this U or the risk factor that mediate this collider path, we might adjust from them and remove some of the bias. Quantitative bias analysis may be useful, helping us to illustrate this bias or even adjust for this bias in a quantitative bias analysis method. So today we might hear from novel method from Mark and Marianne about addressing some of this selection bias. So I would like to acknowledge my mentors that helping me with the work and funding and the future contact where you can find me at Yale. Thank you.